So our second goal today is we are going to solve systems of inequalities. So I'm going to create a coordinate plane inside of my graph paper. My first t-table, because it's a vertical line, has -1 for all of its x's. Pick any 3 y's that you would like. For my second one, it is also a vertical boundary line. All of its x's are 3. Choose any y's that you would like. The next thing when you are graphing systems of inequalities, how do you know if the boundary line is dotted or solid? How do you know? Good. So if it says that the line is only going to be greater than, or the shading is only going to be greater than, what do you do with the boundary line? How do you represent that this guy has shading but does not include the boundary line? How are you going to represent that on a graph? Dotted line. So the first thing I'm going to do is plot my 3 points, -1, -1, -1, 0, -1, 1. I'm going to create my dotted boundary line, represented, as Harrison said, if it's greater than or less than, it is a dotted boundary line, and that was exactly what he said. However, what if it is greater than, equal to, or less than equal to? What kind of a boundary line is that? Good, solid. Now, if we are talking about x being greater than -1, and I want to use a test point, say I test the point 0, 0. Is 0 greater than -1, true or false? True. So that means I'm shading towards the direction of the test point. Next, I'm going to graph x is less than 3. So I'm going to use my ordered pair first. 1, 2, 3, up 1, go right 3, stay at 0, go right 3, go down 1. Is this boundary line solid or dotted? Good, dotted. Now I'm going to use the test point 0, 0 again. You can use 0, 0 as long as it's not on the boundary line. Is 0 less than 3, true or false? True or false? It's true. So you shade towards 0, 0. And because it is a system of equations, we only want the part where it's true for both. So where would you all shade really heavily? In between the lines. The last thing that you go back and do on each problem is graph the boundary line and give its equation a name. So this was x is greater than -1, and this boundary line goes with the graph x is less than 3. So make sure you go back and put your boundary line equations on there. Is there a possibility you might get one that says no solution? Is that possible? It is. Why? What if they don't touch, right? What if this guy was shaded greater than and this guy was shaded less than? Would they ever touch? No. So it's possible to have no solution. Let's jump, leave space. Let's count off 1, 2, 3. Let's count off enough space so that you can put number 5 in this box. Let's just go ahead and write the problem. X is less than or equal to 2. Y is less than or equal to 5. And then let's go down and put 6 in this bottom section that's left. 6 is y is greater than or equal to 5, and y is less than or equal to 1. Then let's jump up there and do number 7 together.
What's the other equation on 7?
There it is.